All right, boys and girls, we are back at it again. Multiplying decimals, it's the same but different. You need to remember that we do not line them up. Instead, multiplying decimals is not part of COAS, so it is a different, totally different two-step process. Step one, playing pretend. You guys did a great job with that yesterday. Step two, put that decimal back into our answer. Let's go through some examples. So again, step one, playing pretend. We want to pretend the problem has no decimal points. We don't line up the decimals. We simply pull them out of the problem and pretend they're just whole numbers. Rewrite and solve as if they're whole numbers. Step two, put the decimal back in by counting however many digits live in the decimal universe in the problem with both of the factors that we're multiplying together. We want to make sure that wherever we put the decimal point back into the numbers we already have, that there are the same number of digits living in the decimal universe. So let's go ahead and do some examples of step one and step two. So we are dealing with 4 3/10 times 0 and 8/10. So what's really nice about estimating is it really lets you know if your answer makes any sense. So I think we'll do that at the end to check rather than in the beginning. So the first step is to play pretend. So I'm simply going to pretend that this problem says 43. I'm going to pull that decimal point out. And that really says 0.8 without the decimal point, which is just 8. I don't even need to worry about that 0. So when I'm solving this, it becomes 43 times 8, which is a real simple 2 by 1 digit multiplication problem. 8 times 3 is 24. Carry the 2 next door. 8 times 4 is 32, plus 2 more is 34. So if I were to stop there and think that's my answer, if I do a quick estimation to check, I know that 4 3/10 is about 4. I know 0 and 8/10 is about 1, and 4 times 1 is 4. I can tell you right now, 4 and 344 are nowhere close to each other. That's because we forgot step two, the most important thing. After we pull the decimal point out, we have to make sure we put it back in our final answer. To figure that out, we're going to count however many digits are living in the decimal universe in our original problem. Well, the 4 does not, but the 3 does. The 0 lives in the whole numbers, but 8 is in the 10th place. That's the decimal universe. So you can see we have a total of 2 digits living in the decimal universe, which means we're going to need a total of 2 digits living in the decimal universe with the numbers I'm already looking at. Well, if I put the decimal point here, that would only give 1 digit, so I'm going to need to put it here, and that gives me my 2 digits in the decimal universe. And this makes sense because 4 is not very far from 3 44/100. Let's try another one. Here we have 3/10 times 5/10. So we're going to go ahead and start by playing pretend. We're going to pull the decimal point out. That really just leaves me with 3. Here we're going to pull the decimal point out. That really just leaves me with 5. This is an easy one. I don't even need to set up a problem. 3 times 5 is 15. If I do a quick estimation to check, 0 and 3/10, that is estimating and rounding to 0. 0 and 5/10 rounds up to 1. 0 times 1 is 0, which is nowhere near close enough to our answer of 15. That's because we forgot to put that decimal point back in. If I'm going to count however many digits live in the decimal universe, it's everything to the right of the decimal point. So that would be 1 from that factor and 1 from that factor there. So we have a total of 2. So wherever I put my decimal point, I need to make sure there are 2 digits living in the decimal universe. If I put it here, we have a 1 and a 2 digits living in the decimal universe. I can assume here we have 0 as our whole number, and 0 is really close to 0. Let's try the next one. We're going to start by playing pretend. We have 5 6/10 times 3. By the way, if you were to do this incorrectly and you were to try to line up the decimal points, that would have you put the 3 here, multiply, you would end up doing all this, and you would end up with a much more difficult problem, and your decimal point would be in the wrong place. That is not what we're doing. We want to make sure that we start by playing pretend. We want to eliminate the decimal point. So this becomes 56 times 3. Give that a quick workaroo over here. 3 times 6 is 18. Carry the 1 to the tens place. And 3 times 5 is 15, plus 1 is 16. We look like we're dealing with a 1, 6, 8, but we must make sure that we do step 2. After we take the decimal points out, we need to make sure we put them back in our final answer. If I count how many digits live in the decimal universe, the 5 does not. That's to the left of the decimal. But we have 1 here. I had a lot of students telling me that this whole number right here, whatever that single digit whole number is part of the decimal universe. It is not. In order for it to be part of the decimal universe, it needs to be to the right of a decimal point. This doesn't even have a decimal point. It's just a plain old whole number. So we know that there's only going to be 1 decimal place value in my answer. When I put my decimal point here, that gives me my 1 decimal place value. Some quick rounding, 5 6/10 rounds to 6. And 3 stays 3. 6 times 3 is 18. 18 is really close to 16 8/10. If I were to put my decimal point in the wrong place, let me get rid of that. Let's say I accidentally thought that this was a decimal universe number. That would give me 2 decimal universe spaces, which would be here. And I can see by my estimation, 18 is not very close to 1. So that is why that is not correct. We need to make sure that we put our decimal point in the correct place value based on how many real digits there are in the decimal universe. Let's do another one. We are going to start by playing pretend. We're going to pretend it's not a multiplying decimals problem, just a regular whole number decimals problem by changing this to 903, getting rid of that decimal. 2.6 becomes 26. And yes, this is going to be a little bit more work because this is our 2-digit multiplication problem. I'm going to go through it super quick here. 6 times 3 is 18. Carry the 1 next door. 6 times 0 is 0, plus 1 is 1, and 6 times 9 is 54. That is not my answer. I'm done with the 6 and done with the 1. I'm now going to move to the 2. Since that 2 is really worth 20, I can't forget to put that 0 here to hold that place value. 2 times 3 is 6. 2 times 0 is 0, and 2 times 9 is 18. Add these guys up, make some room. We have 8 plus 0 is 8, 1 plus 6 is 7, 4 plus 0 is 4, 5 plus 8 is 13, carry that 1, and 1 plus 1 is 2. A lot of you guys are trying to put commas in there. We don't want to put the comma in because we are going to put a decimal point somewhere in those digits. The question is, where do we put the decimal point? I need to count how many digits live in the decimal universe. We have a 1, a 2, and a 3. So I know wherever I put that decimal point, I must put 3 digits in the decimal universe. If I put it here, that would only be 2, the 7 and the 8. So it's going to go here, which gives me a 1, a 2, and a 3 digits in the decimal universe. A quick estimation of the product, 9 and 3/10 is about 9, 2 and 6/10 is about 3, and 9 times 3 is 27. If I had put this decimal point anywhere else, it would not have given me a number as close to our estimate, and that would have proven us wrong. Ladies and gentlemen, you can see we are finished, but you can watch this video again, and you can look back and listen, but it goes back to the same old, same old. Step 1, playing pretend. You know how to multiply whole numbers. Pretend there's no decimal points, and rewrite it and solve it. Once you have the digits, now you need to place that decimal point by counting the digits in the decimal universe and making sure that the answer has the same number of digits in the decimal universe. Get a move on, and please see a teacher if you have any questions whatsoever. You can do it.